9.4, number 35, we're asked to do two things: find the interval of convergence, and then write the sum of the series as a function of x. So where does it converge? Well, we know it converges as long as whatever your r is between -1 and 1. So our r is whatever is being taken to the nth power. So that'll be this right here is your r. So this, the absolute value of it has to be less than 1. Well, we can multiply both sides by 4. Oops, 4. Square root. So x minus 1 absolute value is less than 2. It'll never be less than -2 because this has to be positive. So we have x minus 1 is less than 2, and the opposite of x minus 1 is less than 2. So x is less than 3. Divide by -1, so x is greater than -1. Alright, so our interval of convergence is from -1 to 3. When it's in this form here, we could have found that because the center is 1 and our radius is 2. So on our number line, if our center is 1 and our radius is 2, we go 2 in each direction, then we'll get 3, -1, so from -1 to 3 is our interval of convergence. If you didn't want to solve these inequalities, you could just look at that, as long as it's written in that form, x minus a less than. So how do we write the sum of the series as a function? So back we'll use the fact that our initial over 1 minus r is the sum of an infinite series. So infinite geometric series. So our initial, if you go back here, plug in 0, it's just going to be 1 over 1 minus r, which is x minus 1 squared over 4. So just simplifying that, I'll multiply the top and bottom by 4, so I get 4 over 4 minus x minus 1 squared. And probably a decent form for the answer. That's what I would go with.